Okay, this is a glass of orange juice. Orange juice is squeezed out of oranges. That's how we get it, right? And they bring in hundreds and hundreds of thousands of oranges grown in Florida or Mexico or wherever, and they put them in these big, big vats and they squeeze them. They put them in conveyor belts and they squeeze them and they get everything out of them that they can. They use the pulp and the extra matter from the orange that's not juice, and they put that back into animal feed and they try and use as much of it as they can. So let's think about triangles. How many pieces of information can I squeeze out of a triangle? Well, I've got 3 sides and 3 angles. Let's think about this. Three sides and 3 angles, that's 6 sides. There's 6 pieces of information. If I have 6 pieces of information in one triangle and I have corresponding triangle with 6 of the same pieces of information in that triangle, then I can know for sure that those 2 triangles are congruent. What the triangle congruence theorems that we're learning say is that I can actually have that affirmation. I can know that those triangles are congruent with less than 6 pieces of information. All I need is 3. So we've gone over a bunch of them. The ones we've gone over so far are the SSS triangle congruence theorem, that's side, side, side triangle congruence theorem. We've gone over the side angle side triangle congruence theorem, that's SAS. We've gone over the angle side angle triangle congruence theorem, ASA, and then we've gone over the angle angle side triangle congruence theorem. We're going to learn 2 more today. The first one is called the hypotenuse leg triangle congruence theorem, that has to do with right triangles only. And then the second is a manipulation on one we talked about before called the ambiguous case. That's the SsA, which we say in that order for obvious reasons. Then there's a third that's kind of a subset of the SsA, which would be a capital S, lowercase s, A triangle congruence theorem. And that is more concrete than the ambiguous case. And you'll learn why here in a second.